Dear students, in today's class we discuss partition values. That is partition values. So what are partition values? Partition values are when we collect data from the field, we arrange them in order, that is either ascending order or descending order. Then we divide it in equal number of equal parts. So here equal parts, we may divide the data, it may be in 2 equal parts, 4 equal parts and 10 equal parts, or maybe even 100 equal parts. So when we divide in equal parts, we get the certain number of values. When we divide 2 equal parts, in the center we get 1 value. And when we divide in 4 equal parts, we get in between 3 values. So like that, here we get certain number of values when we divide the data, and that values are called as partition values. When we divide the data into 2 equal parts, we get one single value, and that is called as median. And when we divide the data into 4 equal parts, that is called as quartiles, and there we get 3 values. And when we divide the data into 10 equal parts, we call it as the deciles, and we get 9 values. And when we divide the data into 100 equal parts, we get 99 values. They are denoted by we get 99 values, and they are denoted by with the first letter P, P1, P2, P3, P4 till P99. And quartiles values are denoted by its first letter Q, capital Q, and Q1, Q2, Q3. And deciles are denoted by its first letter capital D, and D1, D2, D3 till D9. And here, how do we get these partition values? So as I said, when we divide the data into 2 equal parts, we get median. And in the same way, we identify, or we calculate or find the partition values. And here we follow the same process. That is first step. Here no formula for ungrouped data to find the partition values. Instead we follow the steps. So that is, first we arrange the data in order for ungrouped data. For ungrouped data, first step, we arrange the data in ascending order. Then we make just a simple formula for QI or DI or PI. The formula is I into bracket n plus 1 divided by, that is either 4 for quartiles, 10 for deciles, and 100 for percentiles. So that value, the observation which lies on n plus 1 into I divided by 4, we get quartile. So first, to get first quartile, 1 into n plus 1 divided by 4. To get second quartile, 2 into bracket n plus 1 divided by 4. To get third quartile, 3 into n plus 1 divided by 4. And deciles, to get D3, third decile, 3 into bracket n plus 1 divided by 10 to get a 9th decile. So we do 9 into bracket n plus 1 divided by 10. And in the same way, to get the percentiles, so I value we multiply with for n plus 1, then we divide it by 100. For example, if it want to find P85, so 85 into bracket n plus 1 divided by 100. So that observation, the observation which lies at that position is that partition value. So for example, if you take here 2, 5, 8, 10, 15, 19, 25 and 30. So these values we have here, okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 observations are there here. So first let us find Q1. Q1 is also known as lower quartile, and it is the first quartile also. Here formula is I plus, I is 1 here, so 1 into bracket n plus 1. So n is 8, as we have a 8 observation here. So 8 plus 1, 1th observation divided by 4. So here 1 into bracket 8 plus 1 divided by 4th observation. So 8 plus 1 is 9. 9 into 1, 9. 9 divided by 5. 9 divided by 5 is 2.25. So our Q1 value lies in the place 2.25, that is in between second and third value. So where it lies exactly here? After second observation, but before third observation. In between these two observations, but it takes only 0.25 of the difference of these two observations here. So to find Q1, a small calculation we have to do to find the exact value. That is, first we take a second observation plus, now we know that it is after second value but before third value. But what is the range here? That 0.25. So we do here 0.25 into bracket third observation minus second observation, as it lies in between second and third observation. The difference of third and second observation, we multiply it with the next digit after decimal point, that is 0.25. So that here second observation is 5 plus 0.25 into bracket third observation is 8 minus second observation is 5. So 8 minus 5 is 3. 3 into 0.25. 3 into 0.25. Okay. That is 0.75. 0.75. So the final answer is 5.75. So the first quartile Q1 value for the given observation is 5.75. So like that, if you want to find the third quartile, that is Q3 for the same data. So if you want to find third quartile, that is a Q3 for the same observation here. So the formula for Q3 is Q3 is equal to 3 into bracket 8 plus 1 divided by 4th observation. So 8 plus 1, 9. 9 into 3, 27. 27 divided by 4. 27 divided by 4 is 6.75. 6.75, that is our answer is the Q3 value lies in the place of in between 6th and 7th observation. So 1, 2, 3, 4, 5, 6, 7, that is in between these two values Q3 is lying, that is 19 and 25. So where it lies exactly? So to get that we have to write the formula, that is 6th observation plus 0.75 into bracket 7th observation minus 6th observation. So here 6th observation is 19 plus 0.75 into bracket 25 minus 19. So 19 plus 25 minus 19 is 6. 6 into 0.75. 6 into 0.75 is 4.5. 4.5. So therefore the final answer of Q3 is equal to 19 plus 4.5 is equal to 23.5. So Q3 value for the given observation is 23.5. Now in the same way let us find deciles. So let us take new values here: 3, 10, 15, 18, 25, 27, 30. So 7 observations are there here. So formula for DI is equal to I into bracket n plus 1 divided by 10th observation. So if we want to find D8, that is equal to 8 into bracket, total observation are 7, so n is 7 here. So 7 plus 1 divided by 10th observation. So 7 plus 1 is 8. 8 into 8, 64. 64 divided by 10 is 6.4th observation. So 6.4th observation, that means your answer lies in between 6th and 7th observation, that is in between 27 and 30. Now how to find? In the same way how we found quartile values, that is 6.4th observation, means here 6th observation plus 0.4 into bracket 7th observation minus 6th observation, that is equal to 6th observation is 27 and 7th observation is 30. So 27 plus 0.4 into bracket 30 minus 27, that is equal to 27 plus 30 minus 27 is 3. 3 into 0.4 is 1.2. So finally D8 is equal to 28.2. So this is the D8 value for the given observation. And now let us find percentile value for the given data. Let us take new values: 5, 8, 10, 12, 18, 25, 28, 30. So total 1, 2, 3, 4, 5, 6, 7, 8. 8 observations are there here. Now formula for partition value, Pi is equal to I into bracket n plus 1 divided by 100th observation. Now if you want to find P80 is equal to 80 into bracket n is 8 here, 8 plus 1 divided by 100th observation. So 8 plus 1 is 9, 9 into 80, that is 720. 720 divided by 100 is 7.2. 7.2 observation. So here 7.2th observation means that is the value of P80 lies in between 28 and 30. So 28 and 30, to find the value we write the formula, that is the 7th observation plus 0.2 into bracket 8th observation minus 7th observation. So 7th observation is 28 and 8th observation is 30. So 28 plus 0.2 into bracket 30 minus 28. So 30 minus 28 is 2. 2 into 0.2 is 0.4. So the P80th value is 28.4. So this is how we find partition values for ungrouped data. In our next class, we learn how to find partition values for discrete frequency distribution and also for continuous frequency distribution.